Hi everyone, this is the trailer for my final project, Principles of Big Data Processing. So for my project, I built a pipeline to process sensor data coming from devices like this. So these are the type of controllers many industries use to collect high-speed sensor data. For example, we have these in our cars that open our airbags and fly the planes in autopilot. In my particular example, the controllers write the sensor data in Tdms format. And Tdms looks very similar to Parquet files. They are optimized for fast bulk writing, and they have a header information that holds the metadata and the sensor data, the signal, written as a large array. So just as an example from the industry, how some companies use this Tdms format to collect thousands of sensor data and visualize them on the fly. So this is the type of file format I will be dealing with in this project. So for my project, I will not be using real data from real sensors, but instead I will be using synthetic data. In that case, I did not want to create random noise, but instead decided to feed an image file to the program, and it will digitalize first this into a 2D array, and then slice it into 1D arrays and save each of them as a TDMS file, and feed those TDMS files to the pipeline every second. And this is how the overall pipeline looks like. So we have the data source, the image file here, and one app is slicing it into 1D arrays and feeding them into a folder as one TDMS file per second. And an app here, a Luigi pipeline, refreshes itself every 30 seconds and monitor that folder. So as new files, TDMS files, appear in that folder, he consumes those folders and feeds them into Elasticsearch tree-node cluster. And the Kibana visualization tool is linked to that index and visualizing the data in real time. Not exactly real time, but in a pseudo-real-time manner. And during that overall pipeline, the stream is running. A Flume logging is consuming the log files from Luigi using the exectailf sync. And here's the demo. I have the app working that creates one TDMS file per second and records them to a folder. And I have the Luigi pipeline that monitors that folder and refreshes the pipeline every 30 seconds. And as you see, it marks the files that are processed as complete, so it doesn't process them again. So let's look at our daemon. So in our Luigi pipeline, you see that new files are appearing, being added every 30 seconds to this pipe. So each task here represents a one column, 1D array of the image that I provided initially. And simultaneously, while this pipeline is running, when I refresh my visualization, I see the graph that shows the amount of green colored content of the image, which is a very basic trivial analytics example I added to monitor something. And here's my Flume file sync, monitoring the Luigi server's logs with the tailf exec. And the final result looks something like this. So we have the Kibana visualization. On the x-axis, we have the time. As the time passes, new bars appear, and they measure the amount of green pixels in the image. And each slice is being fed to Elasticsearch, the tree-node cluster, as we discussed. And as we come to the green spots of the image, we show the spikes of the Kibana visualization. So this is the final look that when the entire image is being fed to the pipeline.